All right, the quotient rule is another shortcut for taking the derivatives, but it's probably the longest of the shortcuts that are out there. The idea is you're taking the derivative of a function where you have a fraction, one thing over the top of another. And then to take the derivative, the formula is you take the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function, all over the bottom function squared. So as an example, if you've got f of x equals 2x plus 3 over x squared minus 4, then the derivative of that will be the bottom function, so x squared minus 4, multiplied by the derivative of the top. The derivative of 2x plus 3 is just 2. So minus the top function, 2x plus 3, multiplied by the derivative of the bottom function, 2x, all over the bottom function squared. And most of the time, I do not want you to simplify it. I just want you to leave it in that format at this stage, because that really shows me you know the quotient rule in there. If you can get it into that format, you don't have to do any sort of simplification. Just leave it like that. As another example, if you've got x squared plus 4x plus 3 all divided by x cubed, then g prime of x, it's going to be the bottom function times the derivative of the top, 2x plus 4, minus the top function, x squared plus 4x plus 3, multiplied by the derivative of the bottom function. And I'm just going to use the power rule, bring the 3 down, lower the power by 1, so 3x squared. And then that's all over the bottom function squared. So 3x squared, quantity squared there. Okay, again, you can leave your answer just like that most of the time. You don't have to simplify involved there at all. If you've got a function that looks like 5 over x minus 2, we can use the quotient rule on that. You've got an x in the denominator, particularly something more than just a simple x down there. We have to use the quotient rule on it. So it's going to be the bottom function times the derivative of the top. The derivative of 5 is just 0, minus the top, which is the 5, times the derivative of the bottom. The derivative of x minus 2 would just be 1. You're going to multiply by 1, and then the exponent drops down to a 0, and x to the 0 power is just 1. So it's just 5 times 1, all over the bottom squared, all over x squared. So of course you can leave it like that, but with the 0 in there, it makes cleanup fairly easily. It's minus 5 over x squared for the derivative. Whoops, sorry, I did that wrong. It should be the bottom function, and the bottom function here is x minus 2 squared. And so it should be down here, x minus 2 quantity squared. All right. If you have something like we had something yesterday or the other day where we were doing like 3 over x to the 5th, and we saw one way to do it, sort of well, and actually it's the easier way. You'll probably think it's the easier way, is to think of this as 3 times x to the negative 5 power. And then when you take the derivative, you can just use the product rule, multiply 3. So I'm going to get multiply by negative 5. So get negative 15, x to the negative 6. Subtract 1 for your exponent. So that's how to do it, just using the power rule. But if you really wanted to, you could use the quotient rule on that. And I'm just going to show doing this just to show you that they both work out. I think that you'll agree that making this connection, doing it with the power rule, is way easier than doing it with the quotient rule. But we can do it with the quotient rule. It's the bottom function times the derivative of the top. The derivative of a constant is just 0, minus the top function times the derivative of the bottom, 5x to the 4th, all over the bottom function squared. And really this is the exact same thing. 5x times 0 is 0, and so you're going to get a negative 3 times 5, negative 15x to the 4th. And on the bottom, when you raise powers to powers, you multiply those exponents. It's x to the 10th. It's an x to the 5th times an x to the 5th, so it's 10 x's all multiplied together. And of course, you can reduce that down to an x to the 6th on the bottom. You can cancel those. And that's the exact same thing that we got here using the power rule. So the quotient rule and the power rule will give you the same thing, but you can't always use the power rule. You can only use the power rule when you've got just x to a power down there. If you've got any other weird functions on top, it's going to take a little bit more work to that. Okay, three quick examples, maybe 4 quick examples there, but you kind of want to start doing sort of a mantra in your head as you do it. It's the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all over the bottom function squared. And I kind of say that to myself every time I do it. I've been doing that since I learned the quotient rule, and it kind of helps keep things straight for me. Bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared is our quotient rule there. On the quotient rule, the order matters that you do that. You have to start with the bottom and the derivative of the top because you can't change the order of subtraction. The product rule, it didn't really matter all that much, but with the quotient rule, it's very important. Bottom times the derivative of the top. Those two can change order, but the subtraction part in there, you got to have the bottom times the derivative of the top minus the top times the derivative of the bottom in there. So be sure to do that in order.